Okay, so losing my voice. Okay, so first step, I think of this as being f prime. It's not f prime, but I just think of it that way. So the fundamental theorem says I need to find f first. So I need an antiderivative. None of the rules match that. So I think use substitution. So I'm going to use the trick. So I think of two functions being multiplied. Okay. So the trick says I look at this function. I can pick all of it, maybe. I want you to vote. This means yes, this means no. If this is u, the derivative of my pick has to be this. So works, doesn't work. Show me. So this is u. If this is u, the derivative of my pick has to be this. This means it works. This means it doesn't work. Show me. Okay, some people are mixed up, so listen close. If I choose this as u, u will equal 1 all over x plus 1. To find the derivative, I have to use the quotient rule. So I know it's going to be kind of messy. And I'm trying to see, would it turn out to be this? Yes? No? Show me. Give yourself 2 points for voting. It doesn't work. This derivative is going to be too complex to be this simple. You don't want to talk more about it. So that doesn't work. Well, I can pick this alone. The derivative of my pick has to be the other multiplying function. Show me your vote. Yes? No? Did it work? Did it not work? At this time, if you're doing this, give yourself 2. If you're not doing this, don't give yourself any. If this is u, my derivative is 1. 1 is not this. That did not work. You want to talk about it. I'm done working here. There's nothing else to do. I can choose x. U equal x, never gonna work. So now I come here, and I'm like, okay, well, let's try u equals x squared minus 1. Okay, listen closely to the words. The derivative of my choice must be the entire other multiplying function. So the derivative of this has got to be that, other than maybe a multiplying constant difference. 1 means it's going to work, 2 means it won't. Show me. So here's my choice for u. The derivative of this has to be this. Did it work? Did it not work? Say it out loud, please. What's the derivative here? Say it. X. Ask yourself, is 2x the same as 1 over x plus 1? That's what you're asking. If it's not, you vote this. If they're the same, you vote this. Show me your vote. Doing this, give yourself 2 more. Okay. You want to talk about it, please.
Wait, so I know that we can u can't equal x, but like the derivative of u could equal x, right? In algebra.
Yes, thank
Like
you.
I know not on this problem.
No, perfect question. Yeah, it just took me a minute to figure it out. No, perfect. Yeah, it never helps for u to equal x, but definitely this can happen. Yep, the multiplying constant, we don't care, for sure. 2 points for Sydney. Very good. There's nothing left to pick. So look at the flashcard. Algebra. Okay?
Sorry.
All right. We good? Somebody's good. Okay. So start over. That didn't help. You have to think of something else. The things I've seen in past years, sometimes it helps to factor and divide. Sometimes it helps to distribute. Sometimes it helps to move something from denominator to numerator. Sometimes it helps to take a fraction and break it into two fractions. Ideas? Kennedy?
Factor it out. You have difference of squares.
Yes. Difference of squares. Points for Kennedy. I gave you a ticket today already, right?
Yes.
Okay. I can't give you two, so that was a good comment. Look, please note, we are not changing the limits. We change the limits when we're doing a u substitution. We just did some algebra. So we haven't changed from x to u, we're just using x. These divide to make 1. Question? Now, when two things add, you can just use the rules separately. So this is not f prime, but we kind of thinking of it as being f prime. This is not f, but we think of it as being f. Okay? Fundamental theorem says the value of the integral is the same as the value of f with 1 and 2 plugged in, so you just start plugging stuff in now. Don't forget the big parenthesis. Question? Oh, please, Ken.
Can you explain how you got to where the green box is?
Huh? From here to here?
Yeah.
So when you have an integral, first step, I think of this as being f prime, so I've got to find out. So I need the antiderivative. Because these two terms are adding, I can do them separately. It's never allowed if it's multiplication or division, but adding, subtracting. So this is x to the first. So the rule sheet says this becomes x squared over 2. The antiderivative of 1 is just x. 2 points, Justin? Same thing. 2 points as well. Elena?
Sorry, can you just explain how you got to the green box from the red?
From here to here?
Yeah, I
Okay.
used the expanded power.
Oh, look right. Look on the expanded rule and notice there's a little box that says don't use the rule if n equals 1. No worries. The expanded works, Elena, it just gets kind of messy. So this is better.
Me too.
So, because what's the derivative of x? Now, talk to me. It's 1. No worries, it's not a big deal. I just want you to see it. Does that make sense? Yeah, the derivative of x is 1, hence the antiderivative of 1 is x.
Since you didn't do the use substitution, you don't need to change the limits.
Right. We only changed the limits because they were x limits and we changed to u. They're just still x's, so leave them as x's. Rule. So I did them separately because the first rule is when terms are adding, you can do them separate. So this is x to the first. Look at your sheet. So it's x to the first. So my antiderivative will be x to the 1 plus 1. You got it? 2 points. Anybody else?